Where is my arrow? I mean, what's going on here? My arrow disappears. So, now the length of the string changes. So if we use the formula, when t is 1, we can multiply g to both the sides. That means this one so in this case, the length of the clock, that's the length of the clock pendulum. Yep. And then let's differentiate the equation to find this dt uh, when dl is 0.01. Yep, so if we differentiate this equation, and dl is 0.01, so that means because t is 1, uh, 50, and g is 32.2, so yep, so that's the amount of this dt, and if we approximate this value, that's about yep 0.00613 second. And so this means because dt is positive, as the length of the clock pendulum increases, the period also increases. And when the period increases, does the clock, uh, speeds up or slow down? What's the meaning of increase in period?
Increase in what?
When period of the pendulum clock increases, does it mean that the clock uh, speeds up or slows down?
Slows down.
Yep. So that means in this situation, in C, does the clock gains or loses in a day if it slows down? Uh, if it slows down, that means, let's say after 24 hours, let's lengthen the pendulum clock at 2 p.m., for example, and after one day and the next day 2 p.m. Uh, does the clock indicate uh, 210 or 150 if it slows down, for example? When the clock slows down, it'll be about 150, right? I mean, because it's slow. Uh, uh, if the correct time is 2 p.m., so it loses a day, and we want to find the amount, how much it loses in a day. So that means when the period increases about this second, one day has how many seconds in one day? 1 hour has 3,600 seconds, and it has 24 hours in a day. So we are multiplying these two to this amount. So let's do this by using calculator. So we can multiply here uh, 24 and like this. Yep, so it loses about 530 seconds, and in terms of a minute, let's divide this by 60. It loses about 8.8 minutes, so 8 minutes and 48 seconds. Yeah, so the amount of clock loses in a day is about 8 minutes and 48 seconds. So, if 2 p.m. is the standard, the clock will indicate about uh, one, 1 hour and 52 minutes, 51 minutes, if it loses about 9 minutes. And let's think about this melting ice cube using this equation. So we want to find the time for the ice cube to melt completely. Whenever I click this, arrow disappears. Oh, why? What's the... Yeah, so because V is equal to S cubed in ice cube, if we differentiate this equation, dV over dt is equal to, what's the derivative of S cubed?
3
Yeah,
3s squared.
yeah, 3s squared and ds over dt. And we have this equation, so that means this is equal to this minus 6k s squared. So we can cancel this s squared. That means, so now ds over dt is minus 2k. So this means, because k is constant, uh, in terms of the side length s, the side length constantly decreases as time goes by because of this negative sign. So we can make the equation for the side length. That means s is equal to minus 2kt plus, let's say original side length is s0. Yep. So this is the equation for the side length. And then in this situation, 1/4 of its volume are lost during the first hour. Uh, so that means a volume after 1 hour will be the 3/4 of the original volume. So let's say the side length after 1 hour is S1. And in this case, the t is 1, the unit is hour. So when t is 1, we can make this equation from this like this. When t is 1, s is s1 after 1 hour. Uh, and then let me see. Yeah, where is it? I'm lost a little. Yep, and then we want to find the time when it completely melts. That means at that time the S will be 0. And according to the equation, takes the time taken is S0 over 2k. And in this equation, 2k is equal to S0 minus S1. So instead of 2k, we can change the denominator to S0 minus S1. So at the original, let's say original volume is V0. And then according to this equation, S is the cube root of the volume, like this. So we need to use the cube root here. And S1 means, because the V1 is 3/4 of V0, we can change S1 to cube root of 3/4 V0. So that means we can divide both the numerator and by denominator by this cube root of V0. So if we calculate this, that will give us the time for the cube to melt completely. So we need to use calculator to find this value. That's about 10.9. So let's say it's about 11 hours. 11 hours it will take. Yeah, so that's really the end of chapter 3.